Okay, so here's a word problem where we're going to use the right triangle definition of a trig function at some point. Let's see, from a point on level ground 135 feet from the base of a vertical tower, angle of elevation to the top of the tower is 57 degrees, 20 minutes. Find the height. Okay, so I'm going to draw a picture. Let's say here's the ground. I'm going to do the best I can here. It's not going to be the most beautiful picture you've seen. Vertical tower. Okay, so we'll just draw that here. I don't know exactly what kind of tower. And we're trying to find the height of the tower. So let me call this T for tower. The angle of elevation from a point on the ground, so let's say right here, angle of elevation to the top of the tower. Let's see if I can draw a fairly straight line here. So this angle is 57 degrees, 20 minutes. And I know we may not have done any problems that involved minutes before, so I'll talk about that in just a second. But let's just make sure I've used all the information here. So a point on level ground 135 feet from the base. So that's this distance here is 135 feet. Angle of elevation, find the height of the tower. Okay. So we've got all the information kind of summarized in this picture here. I'm going to get to the minutes if you're worried about that, but I'm going to put that off just a bit longer. So when we decide which trig function we want to use, I think it helps to label, if we're going to use right triangle definition of the trig function, so the good old SOHCAHTOA, let's label the sides of the triangle as opposite, adjacent, hypotenuse, whatever. So we want to find the height of the tower. So we want to find this side length here, which is opposite of that given angle. So this is the opposite side. And we're given this horizontal distance here to the base of the tower. So that's the adjacent side to that 57 degree, 20 minute angle. The dog might bark, his ears perked up, so hopefully not. But the hypotenuse will be the side that's opposite of the right angle, and so that's not, the hypotenuse is the distance from like the observer down here to the top of the tower. That's not involved in this problem at all, so we don't really need to involve the hypotenuse. So you look at which trig function involves opposite side and adjacent side. So opposite and adjacent, that's the tangent function. So I'm going to want to use the tangent function to set up an equation to solve this problem. And what that equation looks like, so it'll be tangent is opposite over adjacent. So tangent of the angle 57 degrees, 20 minutes is equal to the length of the opposite side, so that's T, that's what we're trying to solve for, over the length of the adjacent side, that's 135. And so if we want to get T by itself, we just have to multiply both sides of this equation times 135. So I'm going to move this down. So the side length T that we're looking for is equal to 135 times tangent of 57 degrees and 20 minutes. Now, if you haven't worked with minutes before, there are 60 minutes are a way to further break down a degree. So say you zoom in and here's an angle, let's say, that measures 1 degree. So if you take that 1 degree angle and divide it, I can't possibly do this, but imagine you divide it into 60 equal parts. 1/60th of 1 degree is equal to 1 minute. So each of these little tiny angles would be 1 minute. And then when you add up 60 of them, that would be equal to 1 degree. So in other words, if I multiply both sides of this equation times 60, 1 degree is equal to 60 minutes. So usually you don't have a degree button on your calculator, so what we want to do is take something like this and turn it into decimal degrees. So the 57 degrees, 20 minutes is equal to, so that's 57 whole degrees plus 20 minutes out of the 60 that would take to make a whole degree, right? So 20 minutes out of the 60, so that's 1/3 of a degree, right? So this is 57 plus 1/3 degrees. But this is the way you can input it into the calculator. So if you want to, if we were given, 20 is kind of a nice number. If you were given like 47 degrees, what you would do is say, okay, so that's 57 whole degrees. I'm sorry, if you had like 47 minutes, is what I meant to say, then you would say plus 47 out of 60. Just in general, if you have minutes, you would put your minutes over 60 and add that to your whole degrees. So if I'm inputting this into the calculator, I would type it in as 135 times tangent of 57 plus 20 over 60, or if you want to reduce that to 1/3, whatever you prefer. Actually, I'm going to write it as 20 over 60, just that way you have a template for whatever number of minutes you have in a problem. That's the way you could input it. Now let me see, I didn't open a calculator ahead of time. Let's see, I'm working on uploading videos. I'm going to go to plain old Desmos, and I know in the window you can't see everything I'm doing, but I'm going to choose scientific calculator. Okay, and so we had 135. This, I'm sorry, I don't know how well this is going to show up for you guys, but 135 times tangent, what is this doing? Try again. 135 times tangent of 57 degrees and 20, whoops, 20 over 60. Okay, close the parentheses. There it is. Okay. And then it's off the screen, but it's giving me 210.5. So if I go back here, T is approximately equal to 210 point, well, wait, did I round correctly? Let's say 0.6. feet. So I guess we had 3 significant figures here. I should probably just round that to 211 feet for the height of the tower.